In this video, we'll be converting from the rectangular to the spherical coordinate system, and we're converting from the spherical to the rectangular coordinate system. Here are some examples, and the first four examples here are points in space, and you want to convert the points from rectangular to spherical and spherical to rectangular. The last three equations represent surfaces in space, and here we want to convert from one system to the other system. So again, you can pause the video now. You can try these on your own using the conversion equations provided in this section, and then come back to the video to see how I work out the solutions. So let's look at the first example, the rectangular point 111. We want to convert that to a spherical point, using the spherical coordinate system. In rectangular, our points are given as x, comma, y, comma, z. And when we convert them to spherical, we want them in the form of rho, that's your distance from the origin, rho, and then your theta, that's your angle from the positive x-axis in the direction of the y-axis, and your angle phi, which is the angle from the positive z-axis. So we want to convert the point 111 to the point in the same location using the spherical coordinate system. Here we have our three conversion equations that we use. The first one is rho squared equals x squared plus y squared plus z squared. So let's use the first one. Rho squared equals our x squared. X is 1, y is 1, and z is 1. So rho squared is equal to 1 squared plus 1 squared plus 1 squared, which is equal to 3. So that means rho is equal to the square root of 3. That distance from the origin is the square root of 3. Our angle theta can be found by using the conversion equation. Tangent theta is equal to y over x. Y is 1 and x is 1. Tangent theta is equal to 1. And tangent theta equals 1 when theta is equal to pi over 4. And you can use the arctan of 1 to find that. In radians, pi over 4, in degrees, it's 45 degrees. Primarily, we use radians here when we're looking at locations in space, using the points. And then finally, our angle phi. Our angle phi can be found using this last conversion equation, where phi is equal to the arc cosine of this fraction. Z is in the numerator. We're going to have 1 in the numerator, and in the denominator, it's the square root of x squared plus y squared plus z squared. Now, we've already calculated x squared plus y squared plus z squared. That's our rho is 3, so rho squared is 3, so rho is square root of 3, and that ends up being the same thing in the denominator. So to find our angle phi, we can use a calculator to find an approximate angle for arc cosine of 1 over the square root of 3, and that's approximately 0.96 radians. Since we're using pi over 4 as our angle theta, then we need to also use radians for our angle phi. So this point, using the spherical coordinate system, we're using square root of 3 as our rho. Our angle theta is pi over 4, and our angle phi is approximately 0.96. Okay, the next point is in rectangular, the point located at -4, 0, 0. Again, that point is in rectangular, so the points are given as x, comma, y, comma, z, and we want to convert it to rho, theta, and phi. We use the same conversion equations. We get rho squared equals x squared, which is -4 quantity squared, plus y squared, 0 squared, plus z squared, also plus 0 squared. So rho squared equals 16, and that will give us rho equals 4. To find the angle theta, if we do tangent theta is equal to y, which is 0, over x, which is -4. Tangent is equal to 0, when the angle theta is equal to 0. Theta equals 0. And then finally, to find the angle phi, we want to find phi, which is equal to the arc cosine, I should put another z there, arc cosine of z, which is 0 over the square root of 16, which is 4. So the arc cosine of 0, we would use that to find our angle phi, which is equal to the pi over 2. So cosine is 0 when the angle is pi over 2. So our point using the spherical coordinate system, convert that, we're going to get rho, which is 4, theta is 0, and phi is pi over 2. Okay, again, we're converting points that are represented in spherical coordinates system here, and we want to convert it to rectangular system. When we're given the points in spherical, the points are given as rho, comma, theta, comma, phi, and we want to convert it to x, comma, y, comma, z. And we can use the conversion equations that are listed above here, where we have x is equal to rho sine phi, so in this case it's going to be 12 sine of pi over 9 times the cosine of theta, and theta is 3 pi over 4. Oops. All right, so x equals 12 sine of pi over 9 times the cosine of 3 pi over 4. That is going to be approximately, if you use a calculator in radian mode, it's approximately, let me erase that a little bit there, negative 2.9. All right, now let's find our y. Y is equal to rho sine phi sine theta. So that's going to be 12 sine of pi over 9 times the sine of 3 pi over 4. Again, you can use a calculator to approximate that as approximately 2.9. And then to find our z, we use z equals, the conversion equation for z equals rho cosine phi. That's going to be 12 times the cosine of pi over 9. And that is approximately 11.3. So our point using the rectangular coordinate system then is going to be negative 2.9, comma 2.9, comma 11.3. Okay, for this, the bottom one on this slide, we want to convert the spherical point to the rectangular. Again, we're given the spherical in terms of rho, theta, and phi, and we want to convert it to x, y, z. Using the conversion equations, x equals rho sine phi cosine theta. It's going to be x equals sine of pi over 2 times the cosine of pi. Okay, when you work that out, you can find that x is equal to negative 6. Using the conversion equation for y, we're going to have y equals rho sine phi sine theta. So rho sine of pi over 2 times the sine of pi. And simplify that, you get y equals 0. Now our z is equal to rho cosine phi, so that is going to equal 6 times the cosine of pi over 2. And when you simplify that, you get 0. So our point using the rectangular system can be expressed as negative 6 comma 0 comma 0. Again, it is a good idea to sketch these points in space and make sure that the coordinates bring you to the same location. Okay, for this example, we want to convert from rectangular to spherical, and this ends up being a cone in space. We can use a conversion equation. It's a surface in space. To do that, what I'm going to do is rearrange the terms here. Now you can do this a couple ways. I'm going to go ahead and start off by writing this, bringing this negative 3z to the other side of the equation. So I get the equation x squared plus y squared. I'm going to leave a blank there and move that minus 3z to the other side. I get a positive 3z squared. Now I want to add something to both sides of the equation here so that I can use one of these conversion equations. The first conversion equation is rho squared equals x squared plus y squared plus z squared. So I am going to add z squared to the left side of the equation. That would make that a pretty simple conversion. Now whatever I add to the left side, I want to add to the right side. So I'm going to add a z squared to the right side of the equation as well. Now we have the equation that can be converted. X squared plus y squared plus z squared can be converted to rho squared. And 3z squared plus z squared, that's equal to 4z squared. And if we use the conversion equation for z, we can write 4z squared as 4 rho squared cosine squared phi. I replace the z with this conversion equation right here. I'm going to continue to simplify this equation by dividing both sides by the rho squared. If you divide by rho squared here, divide by rho squared to make it simpler, we end up with the equation 1 equals 4 cosine squared phi. We can continue to solve this for phi, and I'm going to write it over here so we have some space here. If I divide both sides of that by 4, to simplify, I get 1/4 equals cosine squared phi. I can then take the square root of both sides. I take the square root of the left and the right. I can get the equation 1/2 is equal to the cosine of phi. Now you can solve this for phi using arc cosine of 1/2. Phi equals the inverse cosine or arc cosine of 1/2. And then when you simplify that, you get the equation phi is equal to pi over 3. So this ends up being the surface using the spherical coordinate system is a simple equation where phi equals pi over 3. The angle is equal to pi over 3. That represented in rectangular is x squared plus y squared minus 3z squared equals 0. For this one, I want to convert the spherical to rectangular. I have an angle theta equals 3 pi over 4. Now this, and if you refer to your textbook, that shows some examples. Theta equals 3 pi over 4 is a plane in space. So we can use the tangent theta conversion equation to find, we can say, if we know that tangent theta is equal to y over x, and we replace theta with 3 pi over 4, tangent of 3 pi over 4 is equal to y over x, and the tangent of 3 pi over 4 is negative 1. So if negative 1 is equal to y over x, we can solve this equation for y, and we get y equals negative x. This is an equation of a plane in space. It's parallel to the z-axis. Okay, in our last example here, we want to convert from spherical to rectangular when we have the equation rho equals 2 secant phi. Now what we can do here is um, we can we can let's see, what can we do? Let's go ahead and solve for, okay, sorry about that. We can go ahead and see if we can write it so that it can be easily converted using one of these equations. And we have secant, and I know that's a reciprocal of cosine. So what we can do is we can divide both sides of this equation by secant phi. And when we have rho divided by secant phi equals 2, rho over secant is the same thing as rho times the cosine of phi equals 2. And notice that that is exactly the same thing as we have here. Rho cosine phi can be converted to z equals 2. And that would be the converted equation in rectangular, the plane z equals 2.